This is our AMSAT operations team. Myself, we have 3 satellites currently that we are responsible for. AO7, Mike Seguin, N1JEZ is responsible for 7. AO16 and Mark Hammond, N8MH, takes care of that for us. Right now we don't have any ongoing operations with 16, but we've also worked with IO26 some, trying to restore some functionality there, and that's Mark's area. AO51, Gould Smith, WA4SXM, is our primary command station, along with Kevin Shookman, WA6FWF. He's our West Coast, California command station. When we mess something up on the first 2 passes, he fixes it on the 3rd and 4th, so he's very valuable to us. Mark has just joined us working with AO51 now that 16's sort of wrapped up, and he's learning the ropes on 51. We have an operations committee. Probably most of you guys are familiar with it. We take operations requests, mode requests at AO51 modes, or AO51-modes at amsat.org. We keep it a somewhat international team. We have two members from outside of NA, Ebe Christofferson, OZ1MY, and Colin Hurst, VK5HI. Mark Gould, myself, are members, and Doug Pape, KD8CAO, and Ed Cleo, N8BBQ, are our newest members. They replaced Patrick, WD9EWK, I think it is. So basically, we answer all the questions that come into the modes address and try to put together a schedule every month that meets everyone's requests. We can't always meet them all, but we try the best we can without overloading the command stations with mode changes. And we get a lot of questions too, you know, I didn't hear AO51, why? Things like that, so we try to help out. Just a brief state of the AMSAT fleet. I wish we had that many. Of course, what happened in the end was bad. AO7, right now, just entered back into a period of continuous illumination, doesn't go into eclipse. This is after a period of eclipses from May to July. This is really nice because the 24-hour timer starts working again, and we get regular mode changes between mode A, 2 meters up, 10 meters down, and mode B, 70 centimeters up, 2 meters down. It's amazing that she's still working. The satellite was launched a month after I was born. There's a lot of DX activity been going on AO7. It is currently one of our 2 highest satellites. This is just a screenshot from SAT-PC32, and you can see that the majority of the northwest or northeast and even some of the northern Midwestern states have good windows into Europe, especially northern Europe. Even from my ground station here in Florida, I can work probably about into this area here and have regular QSOs with some of the stations here in the UK. For the 2 or 3 of us from North America that are here, we also get good windows, DX windows into South America, and there are quite a few active stations there. A lot of Brazilians, basically all the top tier countries across the top of South America have active operators. So it's a lot of DX call signs on the air there. AO16, we had a brief revival when we figured out we could loop back the uplink receiver into the double sideband or reduced carrier AM transmitter, and that was good for a while. What has happened is there is a watchdog timer in all of the original microsats that has degraded over time and fires much too quickly now, and basically resets the computer back to shuts it off. And this was temperature related. So when we were in continuous illumination with AO16 and it was nice and warm, basically anything above about 14 or 15 degrees Celsius, that watchdog timer quit firing so fast. So we could set the mode up and let it run. Now when we fire the transmitter up, it only stays up for less than a minute usually. So unfortunately, the orbit is drifted, and we will not have continuous illumination or enough illumination if things don't change for several years from now. So if I'm still active with things in 5 or 6 years, or I'll pass the information on, we may have it yet again. One of the things that I keep pushing about AO16, and the same thing was with UO14, if you're going to build a digital satellite, put a backup interconnect between your receiver and your transmitter. When your computer dies, you can still do something with your satellite. And that's something that I think every satellite should have built in, this ability to do that. AO51 turned 5 last month. She's just about 100%. There are a few bugs that we found. We no longer run the BBS with a VHF uplink because of some interference issues. The SQRX, which is the tunable receiver, is the only receiver tied to the user BBS inputs. On 2 meters, it desenses our command system for some reason. So that's why we've switched to the L-band uplink on the BBS, unfortunately. We run an incredible amount of modes on this satellite. We have 3 transmitters, 2 UHF transmitters and 1 S-band transmitter. We have 5 receivers, 6 receivers. This SQRX receiver is tunable from DC to daylight, basically. That is our user digital uplink, and anytime we run any of the single sideband uplinks, that's the receiver we're using. And you know, just look at the mode list: VU, VS, LU, LS, L up, U and S both down, V up, U and S both down. It's sometimes hard to keep track of everything we can do with it. This is a graph of the past year or upcoming 2 years in illumination. We're just coming out of a period of full illumination. We're right about here, about 5 minutes of eclipse. Unfortunately, we've had some problems coming into and going out of full illumination. The satellite has some bug in it that it tends to crash the software right around there. If you look back at the software crashes we've had over the last couple of years, they've all been coming into and going out of eclipse. Last night I logged in and started a whole orbit data file since we're trying to keep an eye on things real close around this transition time. I checked my email this morning, and at about 0800 it went silent. So we may have had another software crash. We'll see. We're about to go back into this continuous illumination period that lasts until May of 2010. We've got another brief eclipse period. We get up to 19 minutes, and that lasts until about the 3rd week in August. Another brief full illumination, and then the orbit will have drifted enough by then that this eventually gets up to about 35 minutes and is constant for quite a while. The reason I go into such depth on this is that during these periods we're making an incredible amount of power, and we can do lots of things with very strong downlinks. We get into this period, and especially over into here, we're going to have to change our operational scheme. We can barely run 2 transmitters through eclipse right now, the 2 UHF transmitters. So we'll probably have to drop back to 1 UHF transmitter at a time. Since we need to use one of those at least part of the time to get telemetry, whole orbit data telemetry, we'll probably have to work out some sort of alternating schedule to go in between the 2. Again, more sun is more power, is more downlink for everyone. When we're in full illumination, we can run about 800 milliwatts on both transmitters. If we put all that to one of the UHF transmitters, the efficiency goes up as the power goes up with these transmitters, and we can run close to 2 or 3 watts. The heat has been a real problem. The battery life, not only are they 5 years old, but they've also been cooked through several full illumination periods. They're about 50% of the capacity that they were at launch. So that's going to definitely affect our future operations. During the full illumination periods, it's not a big problem because the batteries only act as a buffer. The satellite doesn't, the power generation isn't smooth, especially on our -Z side because we don't have as many cells on that. About the only time the batteries kick in when we're in full illumination is during the flip when you cross the equator because we're magnetically stabilized. It presents the Z- side to the sun and doesn't make as much power. So for that minute or two, we're pulling off the batteries. The rest of the time, they're basically float charging. So we always try to do new things on 51 since we have so many modes to choose from and we have active control of it. We've had college radio nights. In the U.S., that was very well received. Lots of CubeSat active universities were on the air. We're looking to restart those sometime in September, probably once or twice a month. This year when we had all the activity on slow scan from the ISS, before that we opened up the secondary repeater on AO51 for SSTV, and lots of people really enjoyed that. These are just some of the images that people sent in of slow scan transmissions that they copied. You'll see some familiar calls here. Japan. This one's neat. Top of a glacier in Canada. We had a D expedition. How many people work K5D? Anybody here work K5D maybe on HF? Well, K5D is Desecheo Island. It's an American territory that they haven't allowed anybody on for quite a while. So there was a D expedition going there. They were completely HF oriented, but myself and a couple other AMSAT members got a hold of them and begged them to take a minimum satellite station with them. So we arranged for a donation of a D7 handheld and an arrow. It was as much as they were willing to pack in their personal luggage. And most of the contacts they made were on SO50 and AO51, a few on the ISS repeater. So AMSAT NA still has that gear that we're trying to actively loan out to any D expeditions. Just some pictures from the island. Operation Gary, I think his call is K8YG. He was telling me that they weren't really thrilled, all the rest of the operators weren't really thrilled about the satellite being included, but by the end of the D expedition, they would all come out to watch the passes, and I hope this is going to work here. At the end, their last contact was a station on the ISS. Let me play a bit of the audio here. So having a contact with the astronauts on the ISS is a pretty good way to wrap up your D expedition. We had the AO51 Apollo 11 event last Monday night. We wanted to do another special event, sort of like the Sputnik event we did last October. That was pretty well received. This time we changed things up a little bit and included a slow scan image. We don't have any way to store an audio message on 51, so we pick an L-band frequency, a secret frequency, and we have volunteer ground stations relay the message through the satellite. We shut all but one transmitter down. We were running about 1.5 watts, so had a good decent downlink signal. This is the image we started out with, and let me play you a bit of the audio.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Contact light. Okay, engine stop. Houston, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
And then the slow scan message. So we had volunteer uplink stations in North America, Japan, Europe, and South Africa. We couldn't find one in Australia in time. Colin had some other duties that evening. These are some of the images that folks copied off the satellite and sent in. This one from ZS1LS, Alan, is particularly nice. He may have cheated, though. He was one of the uplink stations. Now, he's got a great station. Here's one from here, copied in the UK, G4PIR. So we'll sort of switch gears here from operations type things to just a general AMSAT North America update. We are in a little bit of a rebuilding mode. I won't deny that. We're getting things together and trying to move forward despite some of the obstacles that have been placed in our path. The AMSAT lab, most of you know that we had an agreement with a university in Maryland and we had shared lab space. That went sour. One of the organizations with the university that we were involved with went commercial, and things went downhill from there, and no use crying over spilt milk. But we have learned from the process and are moving on. Most of our equipment is currently in storage, except the clean room. The clean room is still on site, and unfortunately we've had to involve lawyers in litigation to try to get it released to us. We're currently in very promising discussions with a major university. I can't say who quite yet. Things are looking very good. They have an active space program already and are looking to expand, and they think that we may be a good fit for them. I'm very, very, very hopeful that this opportunity will work out. I think it'll be a really good one, and when folks find out who it is, they'll be happy. ITAR, that's a four-letter word. I've used several four-letter words with that. International Traffic and Arms Restrictions. If you haven't heard of ITAR before, it's basically a law that tries to regulate and restrict the spread of knowledge and material that may be used for military purposes outside of the U.S. Unfortunately, that includes satellites, and they painted it with a very broad stroke, including amateur satellites. Basically anything that goes into space can be considered an arm. We are making progress towards getting around ITAR, working with ITAR. Last month we filed a voluntary disclosure with the State Department. We basically have told them everything we've done in the past 5 years, which is the window, the sort of statute of limitations. The State Department did agree that we violated ITAR, but they wouldn't tell us exactly what the violations were. It was not totally helpful. They did say don't worry about what you've done, just don't do it again, but we're not going to tell you what you've done. So we're trying to arrange a meeting with State Department to hopefully identify more specifically where we broke the law. This is serious. We've had some AMSAT members that were threatened with well, prison time. So hopefully we'll be able to get around that soon and start working with our international partners again. It's okay if you send us stuff. We just can't send you anything. More on ITAR. We also recently filed 4 pieces of paperwork called commodity jurisdiction requests. If these get approved, basically what they do is they ask to move a certain piece of hardware or knowledge or area from ITAR and State Department jurisdiction to the Commerce Department and export regulation jurisdiction, which is much easier to deal with, and you don't go to prison for so long. Yeah. The items that we have filed for were all related to P3E, the SDX, the CAN-do modules and system, the IHU3, and any thermal design and modeling. We fully are aware that we may be late on this, but we have to start somewhere. If we can get these passed, we'll be able to hopefully help Peter and crew out as best we can with what you have left to do. And as importantly, we will have sort of navigated the paperwork and figured out how to do these for future things. So if we have another project that comes up that we want to work with foreign nationals on, we can try to submit these and get it cleared. If these go through, we will not need a TAA, the Technical Assistance Agreement, which has been sort of the major hang point with AMSAT-UK and DL and us. And I don't blame you. I wouldn't sign one either. So last year, if you've kept up, we sort of had a little implosion in engineering. I won't go into that, but try to recover from that, and until we find another volunteer for VP of Engineering, we formed a committee now, or task force. Normally committees, you know, everybody knows the saying about engineering by committee, but this one has been working out really good. Our members, Bill Ress is in the lead, N6GHZ. You'll probably recognize these names, Tony Montero, AA2TX. If you've ever built an antenna out of an AMSAT symposium proceedings, it was probably one of Tony's. Lou McFadden, Tom Clark, and myself. I'm there mainly for operations input. Our initial objective was to review Tom's proposal for the geostationary Intelsat rideshare opportunity. We unfortunately were not successful with Intelsat. They asked for a lot of money, which we couldn't do. But it kind of opened the door and got us to thinking about what we can do with other rideshare possibilities. If we can't get a satellite of our own to the orbit we want, maybe we can hitch on somebody else's. That's working out very good, and it's sort of become the way of thinking for the task force. One of our other objectives was to support and finish SUITSAT-2. It's vital that we get SUITSAT-2 done and that it works. We are looking to use the modules and the expertise that we developed during SUITSAT-2 for future missions, especially the SDX. So back looking at how we might take advantage of rideshare opportunities that may be very short fuse, short time in nature. We went through and cataloged all the existing modules and we're starting to develop new modules that can be used to rapidly assemble a system of proven pieces that can be used to meet an opportunity in a short amount of time. And we're not going to be picky. If somebody offers us a ride to LEO, we're going to go to LEO. If somebody offers us a ride to HEO or on a GPS satellite or something like that, we're going to go. We can either build what we can and aim for a goal, or sit around and aim for a goal. And we're going to build. We've got to build and fly stuff to survive. The other objective, to follow on to the modular approach, is we need to identify launch opportunities. The days of building a spacecraft and then going and finding the launch may be over, as far as I see it. We need to identify the launch opportunities, the size of the shape of the envelope, and build to match it. We have to do that quickly, so we need to be able to pull things off the shelf. We actually have several opportunities that we're exploring right now. Probably the one that's foremost in my mind, and excuse me that I can't give you any specific names or anything like that at this point. We're looking at a secondary package on a large university satellite going to LEO, about 100 to 150 kilogram satellite. We've been offered 10 to 15 watts of DC available 24/7. The current proposal, you see a UV-FM repeater in here. This may or may not be available. The idea is it will function as a backup comm system, much like Graham's has proposed for ESEO. If they don't use it for their backup comm system, we'll be able to just bent pipe it and use it for a UV repeater. The hardware we're looking at right now is capable of several watts on the downlink, so it'll truly be an HT satellite. Along with that, because there was the possibility that if they need it, we could have an investment that we wouldn't get to use. Along with that, we're proposing to fly a UV SDX transponder and possibly the camera system from AMSAT-2. This will be pretty neat to have continuous slow scan images coming down from even a LEO orbit. This will be a good educational outreach. Try to identify where the picture is. Lots of different things you can do with that. Another opportunity, we're in discussions with a small spacecraft manufacturer, as of yet unnamed, about including some secondary packages on one or more of their launches. These would typically be a single purpose type mission, a transponder, a repeater, a BBS, something, one set of frequencies, one use, that would occupy maybe one tray in size. We've got more. We have tentative approval for a very small package on a little test satellite going to GTO. So far they've offered us 4x4 by 2 inches and 1 watt of power. That's about a half U CubeSat. Probably not going to be a transponder everybody's going to use. But if we can get a small transponder on there, you may be able to use it for PSK-31 when it's out between perigee and apogee, and you might be able to eke a couple of voice QSOs out of it as it swings by on the low part of the orbit. It's free space and a free ride. We may have to include some sort of telemetry, so we're looking at a 400 baud PSK FEC encoded downlink as a secondary telemetry for them. If we get in their good graces, maybe they'll take us back to GTO again on a bigger ride. A little more power, a little more space. A lot of things we still don't know about it. It's very much in the planning stages. I mainly mention it just to show that we are working actively to try to find these opportunities. We don't know how they're going to be stabilized. We don't know what frequencies they're going to be using, so that will influence what we use. So if at all possible, we're going to squeeze some sort of two-way package on that. SUTSAT-2, well, maybe it's not SUTSAT anymore. Unfortunately, due to space issues, the 2 Orlan suits that we were going to stuff SUTSAT into one of them, well, they're ash somewhere right now. They were loaded into the Progress that was detached. I don't know if it's re-entered yet or not, but they're not going to be available. And to make up for that, the Russians told us that we could build a space frame to hold the electronics, and they'll still deploy it, same as before. So other than having to come up with a new name and not being reminded of the scene from 2001 where Frank Poole drifts off into space, the project's pretty much the same except for the space frame. Still looking at delivery this fall. We also have to do NASA safety review and hoping for deployment spring 2010 right now. These modules that we're using for SUITSAT-2, we're already baselining those into future missions. This is a block diagram of the IHU for SUITSAT-2. I think it's mandatory you have to have a block diagram on a presentation like this. One of the important things is that we have inputs for external experiments that will get routed in through the 400 baud PSK downlink on it. This has a lot of applications in future missions. This is a sort of a band plan for SUITSAT-2. We're going to have a 70 centimeter uplink, 16 kilohertz wide transponder. On the downlink, you'll have the transponder. Below the transponder, you have the 400 baud PSK beacon with FEC. We'll have a CW beacon here that will send call signs of everyone involved in the project, and we're foreseeing some sort of contest. How many call signs can you copy from that? The BPSK downlink will contain the experiment downlink data, and right now we're using AO40 receive to receive it. We're sending it as blocks from that. We will also have a FM downlink, 145.95. This will have voice messages on it as well as slow scan images from the cameras. We'll have multiple cameras, and the software looks at it and says, okay, is it black sky or does it have the Earth in it? And it picks whatever has something bright in it. So that should be interesting. So in conclusion, any questions, comments, gripes? If you got a complaint, you need to go see the Cylon.
Okay, thank you, Drew. I'm going to have to cut the questions at this stage as we're overrunning considerably. Drew, you'll be around?
I'll definitely be around.
Any questions if you see Drew directly? Thanks very much indeed.
Thank you.